Okay, we're going to work on fractions, add, subtract, multiply, and divide. The first one we're going to kind of work on is add and subtract. Just do something simple. We're not doing anything fancy. I did combine these with integers since we've been talking about rational numbers. And so I wanted to throw in some integers in. And so I put the rule here for adding and subtracting integer rule. Remember, if the signs are the same, we add the number and we go with the sign of the biggest number. Same thing with, see how the signs are the same? They're both subtract or both add. You add those numbers and then you pick the number that's biggest and you go with that sign. With add and subtract, I just like basically just say the same thing as the subtraction rule. So that way, when the signs are both positive or both negative, I use the same rule for the subtracting because it just makes it simpler for people to so you don't have to get confused with the rules. So let's talk a little bit about a fraction. A fraction is a ratio, and we talk about the letter A is my numerator, and my all right, so we have a ratio here. Ratio is the same thing as fraction. And so the top number is called a numerator and the bottom is called the denominator. We used to say that the mean down, the downward number is the denominator. So that was one easy way to help. So all we're going to do is we're going to take some problems and we're just going to work them and discuss them. All right, so we're going to start with number 1 here. First example. We take 5/4 minus 3/4. All right, so let's talk about this. 5/4, if you notice the numerator is bigger than the denominator. This is called an improper fraction. An improper fraction, and this is what it looks like. An improper fraction is when the numerator is bigger than the denominator. So see, this is an improper fraction. We can convert these into mixed numbers, and mixed number is when you mix a whole number with a fraction. So if I divide 4 into that, I have 1, and I just subtract the 2 since I only did it one time. It makes 1 left over, and 4 stays in my denominator. So these are equivalent. 5/4 or 1 1/4 are the same thing. This is what we call a mixed number. And this is an improper fraction. All right, so we're going to leave it as an improper fraction. The first thing we do when we're adding, subtracting fractions is we look to see if our denominators are alike or unlike. If you can look, the denominators both are 4, so they're alike. And this is nice because all we do is when the denominators are the same, we just add or subtract the numerators. So 5 minus 3 is 2, and the denominator stays the same. We keep it as a 4. Now, it is possible that you might have to reduce your fraction. So in this case, they're both even, so I can divide both of these by 2. So if I divide the top and the bottom by 2, I get 1/2. So 1/2 is my first fraction. All right, let's try another one. All right, so we're going to look at this and we're going to determine the first thing we want to identify is the denominators alike or unalike. Well, if you look, they're both alike. They're both 5s. Because they're both 5s, we can just add or subtract the numerators. Now, remember I've thrown some, I'm going to throw some negative numbers in here. So we're going to have to follow the integer rule here soon. But technically they're both positive. All right. So that's a positive 2/5 and that's a positive 4/5. And so because they're both positive, we will really just add. So 2 plus 4 is 6. And the denominator stays the same. It's a 5. Now, look what kind of fraction it is. It's an improper fraction. All right. So in this case, we're going to go ahead and convert improper fractions into mixed numbers. If we're doing algebraic equations, I'd want you to leave it as an improper fraction. So let's go ahead and add this. Remember, we're going to try to do this in our head. 5 goes into 6 one time. So you just subtract 5 away from 6 only one time, and you have 1 remainder left over, and it's going to be 1/5. So 1 1/5 is my answer here. All right, let's try another one. All right, so I have a whole number. This is a whole number, and I'm subtracting a fraction from a whole number. So there's a couple of ways I could do this. Now I could visualize what do I have left when I have a whole, and I only take 1/5 of it. If you know, 1/6 of it. If you notice, 6 represents a whole. So if I had 6 over 6, that would be one whole. So whenever you see the top number and the bottom number, or actually the numerator and denominator, the same, that represents one whole. All right. So really, since the denominator is 6, and I'm pointing here and kind of showing you this at the same time, if I can look at it, I can see that if I took 1 away from 6, I'd actually have 5. And then I can just take 1 away from the 6. But let's do it this way. I like making these common denominators. My common denominator is going to be a 6. So I'm going to put a 1 here to make them both look like they're fractions. My common denominator is 6. So I'm going to multiply 6 to both sides. Okay, so we're going to multiply 6 to both sides. So what I mean by that is I'm going to take 6 times 6 and 6 over 6. So I'm going to multiply 1 to this right here. I'm going to make this the common denominator. Now, if you think about it, 6 over 6 is 1. And so 1 times 6 is still going to be 6. This one, since it's already a 6, we don't have to touch it. So we don't have to multiply 6 to that. All right, so here we go. 6 times 6 is 36. So this is going to be 36. 6 times 1 is 6. Now think, if I take 6 and go into 36, I still end up with 6. It's still the same number. And we're going to subtract 1, 6 from it. Now I can look at it this way. 36 minus 1 is 35 over 6. I'm subtracting, so I take 36 minus 1. That gives me 35. The common denominator is 6, so I leave it like that. Now, how many times does 6 go into 35? Well, if you don't know, you could divide this. This goes inside the box. This goes outside the box. All right, so I could do it this way if you're not sure. 6 goes into 35 5 times. And then I have 5 left over. I'm not going to use a decimal here. We're just going to leave it as a mixed number. So my answer is going to be 5, because 6 times 5 is 30. And I have 35. So if I subtract 30 from 35, I have 5 6 left over. Now look, if you take 1 6, remember the 1 6, and add it to 5 6, you're going to get one whole. That's what we were talking about before, because you have 6 over 6, and then add that 1 to the 5, and you would get 6. And so remember, this is really 6. All right, so let's try another one. That was a little sloppy in my writing, so we're going to do another one of these. Let's try 8 minus 2/4. All right, so this is just another example I'm creating. We'll call this 5A, because this is not the norm problem. I just wanted to do another one of these. All right, so look, the common denominator is 4, so I want to make this a 4. So I'm going to put a 1 underneath it. And to make this bottom number a 4, I want to multiply 4 to the top and to the bottom. Now, 4 times 8 is 32. 4 times 1 is 4. If I divide 4 into 32, I get 8 minus 2 over 4. Now, I'm going to subtract straight across, because I have a common denominator. Otherwise, they're like terms, or they're like denominators. So 32 minus 2 is 30, and my denominator stays the same. And now I can say, how many times does 4 go into 30? Well, 7 times 4 is 28. 8 times 4 is 32. 38 is too high, so 7. And think about this, is 28. And 28 take away from 30 is 2 left over. And we use the common denominator, or the denominator is 4. I have to reduce my 2/4 because they're both even. So I know my answer is going to be 7 1/2. There, hopefully that made better sense, because the other one was kind of messed up. All right, let's try what happens if we don't have a common denominator, or their denominators are not the same. And let's throw in some integers here. All right, so here we go. I want to make my denominators the same. So I got to think of what number I can make both of these at. Some like to do the multiples. So they'll start listing the multiples of 5 here. That's a weird 30, I know. All right. And we'll do 8. And you can see 40 is my common denominator. So we could do this. I actually like writing them horizontally. Change colors here so you can kind of see this how it stands out here. All right, so look at here, my 5. If I'm going to make this a 40, I go 1, 2, 3, 4, 5, 6, 7, 8. So I multiply the top and the bottom by this 8. The 8, 1, 2, 3, 4, 5. So I multiply the top by 5 and the bottom by 5. Now I multiply straight across. So 8 times 4 is 32, but that's a negative. So I'm going to make it a negative 32 over 40. This one's going to be a negative 7 times 5 is 35. So it's a negative 35. Again, that's 40. My denominators are both 40. So that means I just add the top numbers. Now I got to watch out because I have 2 negatives. You remember what we talked about before? If 2 negatives, you add the numbers and go with the biggest number. So I have 32 plus 35, that's 67. The biggest number is 35 and it's negative, so we're going to keep it negative. And the denominator will stay the same, it's 40. Now, try to visualize how many times will 40 go into 67? Well, if you have 2 of these, that's 80, so it can't be 2. So we're going to say 1, and now I'm just going to subtract 40 from 67. That's 27. And it's going to be a negative, and I'll put a 40 here. Now, I got to try to see if I can reduce this. And this is a multiple of 3s, and this is a multiple of 5 and 10s. And so this is not going to reduce. So my answer here is actually a negative 1 and 27 over 40. Let me rewrite that. Negative 1, 27 over 40. Even though the negative, this is negative, it makes the whole thing negative here. So this is my answer right here. Let's try one more of those. Let's do this one. All right, first thing I want to identify, are my denominators the same? Are they alike? And they're unalike. So that means I probably want to make them the same. So I like to do mine vertically. So I'm going to go ahead and do mine vertically, get it all set up. I want to make the denominators the same. So I got to think, what could I multiply to make both of these? Many kids will just take the bottom number here and just multiply it to the top and bottom, take that denominator, multiply it to the top and bottom here. So otherwise it just kind of take the opposite. So we're going to take 8, multiply it here, take this 3 and multiply it to the top and bottom, multiply straight across. That'd be a negative 8 over 24. And this one would be 9 over 24. Now watch out for this one. This one, you can see the signs are a little different. This one's a minus, this one's a plus. So you remember, if the signs were the same, we would add the numbers. But if the signs are different, we actually subtract the numbers. And we go with the biggest number, the sign on the biggest number. So they're different. So I'm going to say 9 minus 8 is 1. And the denominator is 24. Which number is bigger, 8 or 9? And you know 9's bigger, so it's positive. So my answer is going to be 1, positive 1 over 24. So what if we have a mixed number? So let's throw a mixed number in here. All right. I personally like to make these into improper fractions and then go that route and then change it back. You can avoid that. You can just do it, add the mixed numbers and or add or subtract the whole numbers and then add or subtract the fractions themselves. But I personally like to do the mixed numbers in case you have to borrow. And because if you have to borrow from a whole number to make a fraction, work, then it's always better to to go ahead and change it to an improper fraction in my eyes. So we're going to learn how to review how to change a mixed number into a improper fraction. So we play the little round the world. I've heard horseshoe around the world, but you multiply the denominator with the whole number. Okay, so I'd get 21. And then I would add whatever my answer is. So 7 times 3 is 21. 21 plus 6 makes 27. So my numerator will be 27. My denominator will stay the same. It will be 7. Now watch, we could do that. We just go back like we're changing it. 7 goes into 27 3 times. That gives me 21. 21 from 27 is 6. So I'd have 6 left over. So we're going to go ahead and say this is 27 over 7. All right, let's do the next one. We're going to take 1 and -1 and 1 7, and we're going to do the around the world again. So I'm going to multiply. So that'll give me -7, -7 plus 1. And actually, we probably want to leave the negative out. Let's just multiply the numbers. So that's 7 plus 1 is 8 over 7. And we're going to keep it negative because that is a negative fraction. Okay, the fraction is negative, not the other one. Let me pause this. All right, sorry about that. And so now I'm going to take -8 over 7. That's my other mixed number. And since I can go ahead, since the denominators will be the same, we can just say, we can say plus a -8 sevenths if we want to, or we can just say subtract 8 sevenths. This one's a positive, this one's a negative. See the signs? They're different. The denominators are both the same, so we're going to leave it the same. And now we're going to take 27. And since these are different, like up here, we're going to subtract the numbers. So 27 minus 8 is 19. And now the biggest number is 27. It's positive, so we'll have to worry about the negative. So it'll be a positive. Now, this is an improper fraction, so 7 goes into 19 2 times, and we'll have 5 left over. And 7 will be my denominator. Let's do one more and we'll call it. All right, so let's try. If I could write, let me try that again. Okay, threw a bunch of negatives in here with mixed numbers. All right, so the first thing is I want to change my mixed numbers into improper fractions. Notice that my denominators are not the same, so I'm probably leave it vertically. So here we go, 2 and 5, 6. Remember, there's a negative here. So I'm going to multiply these two. So I get 12. I'm going to come around here and I'm going to add 5 more. So that gives me, remember it's negative, so we're going to say 17 over 6. Again, 6 times 2 is 12. 12 plus 5 is 17. It is a negative sign, so we're going to leave it negative. Let's do the -1 and 1/4. So we're going to multiply. So 4 times 1 is 4. Then we're going to add the 1 to it. That gives me 5 over 4, and the sign is negative. So I'm going to go ahead and write what we vertically. So it's -17 over 6. Now I'm going to do this subtract in a different color. It's right there. And then I got a -5 over 4. Now, in class, we've talked about 2 negatives here is going to change. We're going to add the opposite. I know you're used to saying keep, change, change, but in my classroom, we're learning the proper way to do it. So we're going to keep the first one, of course. All right. So I'm going to kind of like move everything over. So we're going to keep the first one. and we're going to add the opposite. So we're going to change this plus to an add, and the opposite of minus 5/4 is going to be just 5/4. So this is going to be a positive, okay? So it really doesn't matter. So we just have a plus and a minus. So we're just going to, the signs are different. So we need to get a common denominator. So if you notice, I have 6 and I have 4. Now, I could take 4 and multiply it to both, but I think there's a smaller one here. If you look at it, it goes 6, 12, 18. And then 4 goes 4, 8, and 12. So 12 is my common. So we're going to multiply 2 to the bottom and 2 to the top. And then on the fraction on below, we're going to multiply 3 and 3. So this is a lot of work. It's kind of a fun one. So negative 34 over 12. And this is going to be plus. I'm just going to leave it a plus since the other one's positive. 15 over 12. The signs are different. One's a minus and one's a plus. That means I'm going to subtract. So we're going to take 34 minus 15, and I'm going to subtract them. And we get 19. So it's going to be 19 over 12. Which number's bigger, 15 or 34? And hopefully you would say 34. It's a negative, so we're going to keep a negative there. Now, how many times does 12 go into 19? 1. And I'll have 7 left over. 12 is my denominator, and the whole thing is a negative. So it's a negative 7 and 1/12. All right, we'll call that it. If you have any questions, let me know.